Hello, everyone. I'm Michaela Parker, founder and executive director for the Academic Data Science Alliance, and I'm here to welcome you to our Listen and Lunch AI webinars series, where we bring you experts from around the community to share their approaches to incorporating AI in teaching and research in higher education. So today, we'll be learning about the National AI Research Resource, or NAIRR, envisioned as a widely accessible AI research cyber infrastructure that brings together computational resources, data, testbeds, algorithms, software, services, networks, and expertise. The National Science Foundation, in partnership with dozens of federal agencies and private sector contributors, have launched the NAIRR Pilot, which is demonstrating the value and impact of the NAIRR concept by providing this infrastructure to US-based researchers and educators at no cost. In today's webinar, we'll be hearing from Alejandro Suarez, Program Director at the Office of Advanced Cyber Infrastructure at the NSF, who will give us an overview of the NAIRR pilot, resources available, and details on where to go to learn more and apply. But before we begin, I want to remind everyone that this event, like all of our events, is guided by our code of conduct. There is a QR code on this slide where you can learn more about our code of conduct and file an anonymous reporting form if someone makes you feel unsafe or uncomfortable. Also, please don't forget to put your questions in the chat throughout Alejandro's presentation, and we'll take them at the end. For those of you not familiar with ADSA, or the Academic Data Science Alliance, we are a community of data science leaders, practitioners, and educators who believe in a just, equitable future where data science approaches are thoughtfully applied in all domains for the benefit of all. If you want to learn more about our other events and activities, there's a QR code on this slide, as well as our URL, which will take you to our website. So without further ado, I am delighted to welcome Alejandro Suarez, who, as I said, is the Program Director in the NSF Office of Advanced Cyber Infrastructure. He also serves as co-chair of the National AI Research Resource Pilot Program Management Office. Dr. Suarez works on various projects and programs funded by OAC concerning high-performance computing acquisitions, major research instrumentation, software and data infrastructure, and large facilities. Dr. Suarez joined NSF as a AAAS Science and Technology Policy Fellow in 2014 before transitioning to a federal staff role. Prior to joining NSF, Dr. Suarez completed his bachelor's in applied physics from Rensselaer Polytechnic Institute, earned a Ph.D. in computational physics from Penn State University, and served as a National Research Council postdoctoral associate at the U.S. Naval Research Laboratory. Dr. Suarez, thank you so much for joining us, and I turn it over to you.
Thank you so much for that lovely introduction, Michaela, and thank you for giving me the opportunity to present about the National AI Research Resource, or the NAIRR, its vision, and the pilot that we've been working on for the past year. So let me share my screen here. All right, so I can get a lot of the introductories out of the way because of that amazing introduction, so thank you. I want to put a bit of context in terms of where I'm speaking to you from, which is the National Science Foundation's Office of Advanced Cyber Infrastructure. So as Michaela brought up, we work on a lot of different activities that we broadly defined as cyber infrastructure, which is something that is a little bit different than some of the cyber definitions you may have heard from the defense community, for example. This is essentially looking at providing the advanced computing infrastructure, software and data infrastructure, network and cybersecurity infrastructure, learning and workforce development infrastructure, as well as other strategic investments to allow the work of scientists that need computational tools and resources to get their research done. So we do a variety of different investments that are above and beyond what would be the traditional high performance computing investments, though that is something that we are quite known for. And we try to figure out what are all of the different pieces of cyber infrastructure that can most benefit the scientific community. And we are led by our office director, Katie Antipis, who is on a rotation from Lawrence Berkeley National Lab. And we have our deputy office director, Amy Walton, also overseeing us. And we sit within the Directorate of Computer and Information Science and Engineering within NSF. So our office over here on the right complements 3 research divisions that focus on various computer science research activities. What differentiates us from the research divisions within this computer science or SCIES directorate is the fact that the infrastructure that we support is for all of the scientific domains that the National Science Foundation supports. So we support not just computer science researchers, but also researchers from be it geoscience or biology or chemistry or physics or social and behavioral sciences, anyone that is needing computational tools or other cyber infrastructure to get their work done. We are looking at providing that type of infrastructure. And we're, of course, looking at this in the context of many different challenges that are facing this concept on many different fronts. So there is this issue of growth of data amongst detectors, sensors, other scientific instruments. We're in this post-Moore scaling law issue where there is more need for specialized hardware or accelerator technology to be able to most efficiently do computing work and to be able to continue making it faster. There is, of course, as I will talk about today, the rapid advance and integration of AI into all kinds of scientific applications and workflows. There's new business models and entrance into computing and in data infrastructure from our cloud computing colleagues, other private sector entities, these new AI model and other inference services that are coming up. And then there is this scaling need in terms of how do we ensure that the US remains globally competitive and has appropriate access available to researchers to be equally competitive on the global stage. And some of the ways we address this is by enabling discovery through all of these computing data, software, and networking infrastructure investments, by growing and developing communities through workforce development activities, partnerships with industry, other ways to bring up the professionals that can support the scientists doing work that need to use these cyber infrastructure tools, and providing investments and technology adoption and scaling advanced infrastructure through these concepts like cloud computing or working with data center co-location, working with supercomputing investments and other large infrastructure. So this is the stage that I want to set, which leads us to this idea of the NAIRR, or the National AI Research Resource. So the NAIRR is envisioned to really take on this challenge of how we can accelerate the global AI leadership in the US and unlock the enormous AI potential across society. We need to have an AI skilled workforce, and we need to continue driving fundamental innovations, not just within fundamental computer science and AI activities, but also in the variety of scientific applications that are using AI tools in their work. So one of the main barriers that we have seen is that this needs access to computing data, models, software, and expertise to enable this kind of competitiveness. And just relying on industry investment alone may not be seen as sufficient in this. So we have an opportunity here to figure out how can we enable researchers and educators across the US to drive national and regional AI innovation across different sectors and train the AI workforce of the future. So the idea of this NAIRR, this National AI Research Resource, is to have a central portal in which researchers can go in and request access or just find access to computing and software tools, access to data sets and models, access to user support and expertise, or other educational materials and training tools to be able to best effectuate their research workflows. And this is what we've been able to bring up through what we're calling the NAIRR Pilot. So this was just launched a little over a year ago in January of 2024. We have over a dozen agency partners and over 24 non-governmental partners that are all supplying some kind of partnership resource or activity that can help enable researchers get access to the infrastructure that will help them get their science done. And in terms of the infrastructure that's available to researchers, it's a variety of infrastructure. So on the left-hand side, you can see different types of supercomputing investments that the NSF has made, who access to those resources are available for AI research workflows through the NAIRR Pilot. These include our leadership class scale system from Terra at UT Austin. It includes our Jetstream 2 system, which is a cloud-based system, even though it is an on-premise supercomputing center system, and a variety of other systems that use specialized accelerators, that use GPU-based accelerators that have large memory or other computing paradigms to best work with AI workflows. We also have colleagues at the Department of Energy that have supplied access to their AI testbed at Argonne National Laboratory, which has a variety of different accelerator architectures that researchers can experiment with. NIH has made access to their cloud lab available. And last year, we had access available to the Summit supercomputer that was out of Oak Ridge National Laboratory, which was actually due for retirement, but it was extended for another year of operations, partially to support NAIRR workflows, though that one did just retire last fall. And on the right-hand side, you can see the variety of private sector resources that are available for researchers now. This includes a variety of the cloud computing providers, but also a variety of architecture, new computing architecture companies that are providing access to that infrastructure, tools and software companies, special inference systems and services, and APIs to access different kinds of inference models that are available, all available through the NAIRR Pilot. So you can access this today. If you go to nairrpilot.org, we have three main areas in which researchers can request access to this kinds of infrastructure. On the left-hand side, we have a specialized track for classroom, and this is for educators that wish to put together either a training activity or a class that requires a little bit more infrastructure to be able to make it more successful. So such as deploying a set of computational notebooks, having some computing infrastructure behind those notebooks, some orchestration of the notebooks to be able to best manage a large classroom, for example. Those are available through the classroom and educator resources track. The main central track we have here is the researcher resources track. So this is where a variety of either the supercomputing centers, the data and model access and software access and new types of architecture access, all of that can be requested by researchers that have a need for access to computing model software, et cetera, for their research activities. And then on the right-hand side, there is a section that we're calling data models and more. These currently include a variety of government-supported resources that do not require an application. These are open data sets or data sets in which you can request access to through their own mechanisms that could be beneficial for learning more about AI or for use in certain AI research workflows. And it's a very simple process. You apply, say, for the researcher resources track. It's a 3-page application. Eligibility criteria for researchers applying to these tracks is that you have to be a US-based researcher and that you have to be affiliated with a US-based institution, but you only need, for example, a federal grant if you are a small business. This is available to research institutions, institutions of higher education, small businesses, and if you're not a small business, if you're a nonprofit or an institution of higher education, you actually do not need necessarily to show that you have a federal grant, a federal research grant. However, without a federal research grant, there is additional levels of review to make sure that the allocation of resources is being done appropriately. But this is all done through this request process. Within a month or so after applying, you can receive word as to whether you were able to receive an allocation, and then you can get started. And there are 12-month long allocation periods right now through a variety of different resources that I just talked about. And we've been busy. For the past year, we have continued to make allocations available, as well as we have supported through NSF funding a few demonstration and outreach projects. But these blue and teal colors here demonstrate the different resource allocations across the country and classroom projects across the country that have been given access to and have been using NAIRR resources for their work. So it's over 350, over 43 states represented so far, and we're continuing to grow day by day. And going back to the breadth of research that is supported by access to these infrastructures, it goes beyond just the computer science research that is looking at studying AI models themselves, for example. We have work that's going on an agricultural science aspect with some researchers at Iowa State. This is working with one of the NSF-supported AI institutes on training these vision models to be able to better identify insects within an agricultural context, to be able to differentiate between insects that are damaging to crops and can be targeted with pesticides versus insects that may be ecologically beneficial to crops. And so this allows for much more targeted pesticide usage and providing a more nurturing environment for, say, ecologically beneficial insects. We also have healthcare research that's done, for example, on Alzheimer's disease. We have transportation engineering, actual model analysis through computer science research, earth system science. And in the classroom end, we have been supporting anything from as large as 10 to 20 person classes to a deep learning course at North Carolina State University that is supporting 800 students. So varieties of scale there. And speaking of scale, the access to these resources is also quite wide in terms of the scale. And there's some interesting statistics I wanted to share with you all. On the left-hand side is a subset of our NAIRR Pilot awards that were awarded computing cycles on supercomputing resources or cloud computing resources. And this is roughly normalized to what would be GPU compute hours on the y-axis here. And you can see that even without a log scale, it can be a bit harder to see, but there's a huge range in terms of the amount of infrastructure that is being allocated to researchers. On the very left-hand side, for 20% of the projects, these are folks that are running, very small scale computing requirements. They may not have had access on their campus or within their laptop to do a few hundred or a couple thousand hours of GPU compute that was needed for a research project. The big central area is where moderate computing requirements, you could say, where people have a few thousands to tens of thousands of GPU hours that they're asking for, maybe into the little over 100,000. And then on the right-hand side, that last 10%, this is looking at more large-scale requirements. So folks that may be doing either new foundational model training or other types of activities. This is leveraging some of our industry partnerships, such as through the NVIDIA DGX Cloud, through the supercomputing partnerships with Department of Energy, and with the Frontera supercomputer that I talked about earlier, which is a precursor to a major facility that NSF is supporting called the Leadership Class Computing Facility, or LCCF. So this is just to put in perspective that we're not just supporting folks that need to train a large foundation model. They need access to hundreds of thousands or millions of compute hours to be able to do that work. We have a wide variety of applications that are supported through access to NAIRR resources at a wide variety of scales. And the types of activities also quite vary. In addition to just the raw computing or access to GPU resources, access to model and inference, access to classroom type resources, and all alternative compute architecture, such as new accelerator technologies, are also represented on that right-hand chart. What's upcoming in all of this is further emphasis on data. Through the NAIRR Pilot, we have been supporting a data set, dear colleague letter that we have asked the community to provide some data sets that we can highlight through the NAIRR Pilot. And so more will come on that in a moment. So to overall summarize, we've done a lot within the first year. So as noted, it's been just a little over a year that we've been focusing on this. We've been engaging with all of these different resources, providing access to a lot of these different projects. There's more that I could go into in the Q&A, but in the interest of time, I want to be a little bit quicker here. But there's a variety of demonstration projects, this idea of secure computing, community outreach, workshops, data set contributions, and there's more coming for year 2. And some of this was emphasized in a recent inaugural convening we had of all of the researchers involved in the NAIRR pilot back in February. So I just want to really quickly point out that the NAIRR pilot is just one of the activities that the NSF is involved in. And for example, if you're looking at access to this type of cyber infrastructure beyond just artificial intelligence computing needs, we support a variety of different computing services, data platforms of all different kinds. And just one example of that is the Access program, which is a long-standing program who its precursors and it have provided access to supercomputing resources and other tools and services for a few decades now. And this is something that you can also apply to as a US-based researcher at no cost. You can get access to that through access-ci.org. Huge amount of computing resources available as well. I won't go into that list on the right, which if anyone can read text that small, I give you kudos for that, but it's not meant to be read, just a lot, showing a long list of resources we have available. And just finishing up, one of the most recent investments that we made, which is going to be available through Access and is also going to be working closely with the NAIRR pilot in the coming months, is a project called CloudBank 2.0. So we a few years ago, our computer science directorate invested in the CloudBank project, which was supplying cloud credits to researchers within computer science and a few targeted investments at NSF. This new CloudBank 2.0 resource will provide, through this allocation mechanism, access to AWS credits, Google Cloud credits, Azure credits, IBM Cloud credits, and NVIDIA DGX Cloud credits, all through a request process, and it can be done at no cost to researchers. So definitely look out for more information about this in the coming months. So I just have a variety of links here that are available. You can sort of jot these down or take a screenshot, or if you're viewing this on the recording, you can pause here and look into more information. But you can find a recent webinar that was held on how you put together a successful request for access to these resources. There have been a variety of presentations with the NAIRR available at nairrpilot.org/news/video. You can learn about the specific resources and what capabilities they have on the allocations page through NAIRR Pilot. And if you're interested in accessing other cyber infrastructure for other workflows beyond just artificial intelligence, I urge you to look into the access-ci.org program. If you have any other questions about OAC or about some of our investments and what may be available, I left my email address here for you all, but happy to answer questions today. Thank you very much.
That is great. Thank you so much. I just want to remind everyone that they're welcome to drop questions in the chat, but I will get us started while you're all thinking. So this might be covered in one of these links that you have here on the screen, Alejandro, but you mentioned briefly that in order to have a request, it's either required or strongly recommended to have a research grant in hand. And so I'm curious if is there any support within NAIRR for just getting researchers started in thinking how they can use these AI resources in their research? More of a, pre-grant writing, like how would I incorporate this kind of computational power in my research? For folks that might not have an idea of what they could do with this kind of compute.
Yeah, that's a very good point. And I do recommend looking into some of the links on this page. For example, in our video set on nairrpilot.org, we have a variety of researcher showcases. So researchers that were given access previously to NAIRR resources and have been working on a project, they are presenting that work. So it gives an idea of, okay, this is an example of what a workflow looks like and how it interacts with these different resources. With regards to specific resources, There are a variety of events that have been happening in terms of understanding, what the capabilities of some of these resources are, how they may best suit some of your workflows. And if you're looking to just get started, just understand how would my research even benefit from access to any of this, or how do I start choosing? There's actually more coming on that very soon. One of the activities that NSF recently announced a few months back was a program called NAIRR Expansion. And in that, we have been supporting research teams to do a variety of different targeted outreach events. So outreach events to, for example, smaller institutions, to certain specialized institutions, to certain communities that could benefit from understanding how access to these types of infrastructures could best support their work.
That's great. Thank you. And in the meantime, we do have a question in the chat. This is actually what I was thinking about too. How are the NAIRR pilots addressing data privacy and security, especially given some concerns around certain generative AI tools? And I'll add my twist here, because you showed on one of your slides all of these private companies that are involved with NAIRR. I would immediately have this knee-jerk reaction of, are they going to have access to my data or my user profile as I'm doing this work? That's not exactly what's being asked here, but maybe you can include that in your answer.
Sure. So I think there's a few different branches to take on this. So one branch is, how is the NAIRR working through and emphasizing the needs for specialized access or specialized care that is done if you're working with sensitive data of certain types. And so with regards to sensitive data, that again can be split apart into sort of a couple different branches here. There is some of our cloud resources, some of our infrastructure, they can, for example, support specialized data set that may be overseen by federal regulations of some kind, like HIPAA or other health-related data or privacy-related data. So there are mechanisms by which you can ensure that the data that you're taking with you, if it has some of those specific sensitivities, that it can be put on appropriate infrastructure that has appropriate clearances in place. We also have an activity called NAIRR Secure. NAIRR Secure is a partnership that is actually being led by Department of Energy and NIH, and they are looking at what are some ways to best experiment with different compute workflows, looking at very sensitive data, looking at proprietary or health information. And for example, what are ways by which synthetic data could be generated from some of those more protected data sets so that a wider research community can get access to. So that's all one piece of this. I think another piece of this that this questioner may have been asking is just in general, everyone that's bringing their data somewhere, there could be privacy concerns about, if I'm taking my data out of my laptop, what are the concerns going to be? So I think a lot of that is, there are a lot of agreements that are followed between any of the partners that are worked with in terms of how you are maintaining access to your data, who you are granting access to that data. So all of those are governed by essentially the terms of agreement you will have with your systems. Obviously, everyone's going to take care of their data very seriously, and the details about how you would be able to bring your data onto a certain infrastructure and what sensitivities you may be worried about and what protections a different resource may be able to offer about, say, privacy implications of putting data somewhere. Those are best conversations to have specific with the different resources to understand how their offerings can best align with the privacy, security needs or concerns that you may have. So I hope that sort of got to the question a little bit.
Yeah, I think so. Thank you so much. And we are already over time. These webinars always go much quicker than we hope. So I just want to thank you so much again for joining us and for importing all of this great information. I really hope people take advantage of this resource. It is still no cost, and hopefully it stays that way. So thank you so much again for joining us, and have a great rest of your day.
Thank you all.
Thanks. Take care.